When I mentioned those RFCs in the previous video, I did mention that sometimes you'll hear RFC numbers referred to when people talk about a certain address class or a protocol, that kind of thing. I don't mean to make it sound like you got to memorize 100 RFC numbers, because you don't. This is actually the only one I would really be aware of, because you'll actually hear these addresses just called 1918 addresses from time to time. It's like, well, where'd that 1918 come from? RFC 1918 private address class is what we're looking at here. And the thing is, this allows us to reuse certain IP addresses all over the world. You could go to the city that you're in right now, go to a random network, and you probably have a host in that network that's using the 10.111/24 network, or excuse me, IP address. And then halfway across the world from wherever you are, there's another host on another internal network that's using the IP address 10.11/24. Well, how is that possible? Well, it's possible because we have certain address ranges that are where the addresses are non-routable. So these hosts, by default, can't just go out to the internet. They can't even get out of their own little local area network, because their addresses, the router's going to look at it and say, hey, I don't route these packets. Forget it. I'm not sending these out of here. Well, that was okay back in the day when you actually had networks that were designed not to let people go out to the internet. I can vouch for that with the very first school system that I networked. And when we did it, we configured a local area network at every single school, but there was no interconnection at all. Believe it or not. Yes, it was that long ago. Thank you. Nothing wrong with that. But the thing was, the thinking at the time too was, well, we don't want the students, to have network access, because that is evil. And it can still be evil once in a while. But of course, with teachers using, grade programs and grading programs and that kind of thing, all kinds of other programs, and then of course programs to present information to students, we really found that that was pretty impractical. So even though we still have these 1918 private addresses, how do these people get out? How do they get out of their local area network? Well, they use two things: network address translation and port address translation, or I should say we, the network admins, use it. The end users don't even know it's happening. And what happens there is their unroutable address is translated to a routable address. And we will actually configure that later, but I want you to know first off how that happens just generally. But we need to concentrate on these private address ranges for now. I have them expressed here for you three different ways, one on this screen, two on the next. So whichever one you're more comfortable with, but on your exam, be ready to identify an address that's from a private address range and say, okay, we got to do something different here, because by default this address is not routable. Class A, any address from 10.0.0.0 through 10.255.255.255 is a private address. In our Class B range, 172.16.0.0 through 172.31.255.255 is an unroutable address. Class C, the range is 192.168.0.0 through 192.168.255.255. If you prefer, and I would be ready to identify these private classes by the full range or by the ranges I have here for you, they are the exact same range, just expressed first with dotted decimal masks and then a prefix notation mask. So Class A, 10.0.0.0, 255.0.0.0. We know what that means. If the first octet is 10, it doesn't matter what the last three octets are, it's a private address. Class B, this is where we get into those /12 masks. It's not always going to be 8.16.24. Your reserved address range is going to be expressed in dotted decimal 172.16.0.0, 255.240.0.0 with prefix notation 172.16.0.0/12. Class C, 192.168.0.0, dotted decimal mask 255 for the first two octets, 0 for the last two, or a /16 in prefix notation. Whew. I know, when you see the same address range expressed three different ways, it can make your head swim a little bit. I want you to be comfortable, though, with all three ways to express it, whether you're writing it like I have on the screen now, actually showing the first address and the last address in these private address ranges, or expressing them with a dotted decimal or prefix notation mask. It does not matter. Introduction to routing coming up next. We're going to step away from that and start getting our hands on a Cisco router. We're going to do some walkthroughs as well to see what a router and a host are going to do when there is a route to a destination when there is no route to a destination, because that happens too, and we have to know how to remedy that. We're going to do all of that coming up next.